Happy New Year, everyone, and welcome to the Deep Dive. I'm so excited to be kicking off 2025 with you all.
Happy New Year to you, too.
It's January 4th.
Bye.
We're a few days into the new year.
The air does feel especially fresh today. Maybe it's just me.
Maybe it's that 2025 feeling, right? Speaking of the future feeling, today we're diving into something that's been generating a ton of buzz.
Quantum computing.
Yeah. Specifically, Google's new quantum computing chip, Willow.
Right?
You've probably seen the headlines.
Definitely.
But we're going beyond the hype to really understand what this means.
Exactly. We've got a stack of articles and research papers here.
Oh, wow.
Plus a healthy dose of social media reactions. We're going to extract the most interesting nuggets for you.
Okay, let's unpack this. First of all, for anyone who needs a quick refresher, what exactly is quantum computing? I mean, we're not talking about your everyday laptop here, right?
Definitely not. Quantum computing taps into the bizarre world of quantum mechanics, where things work very differently than in our everyday experience. Instead of bits, which are either a 0 or a 1, quantum computers use qubits. These qubits can be in a superposition.
Oh, wow.
Meaning they can be both 0 and 1 at the same time.
Okay, I'm already feeling a little mind-bent.
Yeah.
So where does this Willow chip fit into all of this?
Willow is Google's latest quantum computing chip.
Okay.
And it's causing a stir because it's a significant step toward making quantum computing more practical.
Really?
It's all about scalability and reducing errors. Think of it this way. If you were trying to solve a complex equation, but your calculator kept glitching and giving you wrong answers,
Right.
it wouldn't be very useful, right?
Makes sense.
Yeah.
So Willow is basically a more reliable quantum calculator.
Right.
But how much faster are we talking? The articles mentioned something about mind-blowing speed compared to even supercomputers.
The speed difference is almost impossible to comprehend.
Oh, wow.
Google ran a benchmark test, a specific calculation that would take a state-of-the-art supercomputer 10 septillion years to complete.
10 septillion.
Willow did it in 5 minutes.
5 minutes. 10 septillion. I can't even wrap my head around that number. Could you put that into perspective for us?
Imagine if a supercomputer started that calculation at the moment of the Big Bang.
Oh, wow.
It still wouldn't be done today. That's the kind of computational leap we're talking about.
Okay, that's seriously impressive. And a little intimidating, to be honest. But speed is one thing. What can we actually do with this kind of power? What are the potential real-world applications?
That's where it gets really exciting. One of the most promising areas is drug discovery. Imagine being able to simulate how a drug interacts with the human body at a molecular level. We could design incredibly targeted and effective treatments, potentially even finding cures for diseases that are currently incurable.
That's incredible. So we're talking about personalized medicine tailored to your unique genetic makeup.
Exactly, and it goes beyond medicine.
Oh, wow.
Quantum computing could revolutionize materials science, leading to the development of entirely new materials with properties we can only dream of today.
Like what?
Imagine super strong, lightweight materials for building.
Wow.
Or ultra-efficient solar panels that can power entire cities.
Wow. So from life-saving medicines to clean energy solutions, the possibilities seem almost limitless.
Yeah.
I'm starting to see why everyone's so excited about that.
Absolutely. But of course, with any powerful new technology, there are also concerns and risks that we need to be mindful of.
Right. And some of those anxieties are already surfacing on social media.
Yeah.
The articles mentioned concerns about security, AI, and even autonomous weapons.
It's true.
Should we be worried?
It's important to acknowledge these concerns. Quantum computing does have the potential to break many of the encryption methods we rely on today for online security.
Oh, no.
However, researchers are already working on developing quantum-resistant encryption algorithms.
Okay.
It's a race against time, but the awareness is there.
So it's not like our online banking is suddenly vulnerable. That's reassuring. But what about the concerns regarding AI and autonomous weapons? Those feel a bit more sci-fi, but also a bit more unsettling.
It's true that quantum computing could significantly accelerate AI development, potentially leading to AI systems that are far more sophisticated than anything we have today.
Wow.
This raises important questions about control, ethics, and the potential for unintended consequences.
Yeah, the thought of AI making decisions about warfare is a pretty chilling scenario. It feels like we're stepping into uncharted territory here.
Right.
So what can we do to ensure that this technology is developed and used responsibly?
That's the million-dollar question.
Right.
And I think it starts with open and honest conversations like the one we're having right now.
Yeah.
We need to bring these concerns to the forefront, involve experts from diverse fields,
Okay.
and establish ethical guidelines and regulations for the development and use of quantum computing.
That makes sense. It feels like we've covered a lot of ground already, from the basics of quantum computing to the potential applications and the anxieties it's generating. But there's clearly much more to explore. We're going to take a pause here, but when we come back, we'll delve even deeper into the societal and philosophical implications of this quantum leap. Stay with us.
Welcome back to the Deep Dive.
Thanks for sticking with us.
Before we pause, you were hearing about some potential downsides of quantum computing, things like security risks and AI development getting out of hand. But let's not get swept away by the what-ifs.
Right.
Both good and bad. This tech is still evolving.
Right. It's easy to get caught up in the hype. It's like we're peeking into a future we barely understand. But I think what really struck me in those social media reactions is that people are already thinking about the big implications, not just the cool gadgets.
It's fascinating how these reactions mirror broader anxieties we already have. Take the fear of quantum computers cracking encryption.
Yeah.
That's not just about passwords. It taps into a deeper unease about privacy in the digital age, something you're probably already feeling.
Absolutely. We're sharing more and more of our lives online, and the idea of that information becoming vulnerable is unsettling, to say the least. It's like quantum computing is magnifying those anxieties.
Precisely. And if we zoom out even further, the worries about AI and autonomous weapons,
Right.
they're not just about the tech itself. They're forcing us to confront a fundamental question.
Yeah.
What role do we want technology to play in human society? As tech gets more powerful, how do we ensure it serves us, not the other way around?
That's a huge EE question, and I don't think there are easy answers. But it feels like having these conversations, bringing these anxieties out into the open, is a good place to start.
I agree. We need experts from all fields.
Yeah.
Not just scientists, but
Right.
ethicists, sociologists, even artists to weigh in on this.
Wow.
And we need policymakers to create regulations that can keep pace with this rapidly changing landscape.
So it's not just about building quantum computers, it's about building a future where we can use this technology safely and ethically.
Exactly. We need guardrails, international agreements,
Right.
maybe even entirely new ways of thinking about governance and responsibility in a quantum world. It's a complex challenge, but absolutely essential if we want to navigate this new frontier responsibly.
This makes sense. But let's shift gears a bit and talk about the average person. We've discussed the big picture implications, but how will quantum computing actually impact our daily lives in the years to come? Will we all have quantum computers in our homes?
It's unlikely you'll have a quantum computer in your living room anytime soon.
Okay.
But the ripple effects of this technology will be felt in almost every aspect of our lives.
I can see that.
Think about personalized medicine, where treatments are tailored to your specific genetic makeup.
Okay.
Or imagine ultra-efficient energy sources that could power your home with minimal environmental impact.
Those are some pretty exciting possibilities. So we're talking about a future where quantum computing isn't just a technology, it's woven into the fabric of our lives.
Precisely. And while some of these advancements might seem far off, the groundwork is being laid right now.
It's like we're standing at the edge of a new era, and the choices we make today will determine what that era looks like.
Yeah.
But there's one question that keeps popping up in my mind.
Okay.
With all this talk about quantum computers solving impossible problems,
Yeah.
what are the problems that we should be focusing on? What are the challenges that you would like to see this technology tackle?
That's a great question.
Right.
And it's one that we should all be asking ourselves.
Absolutely.
If quantum computing can solve problems that are currently beyond our reach, what are the most pressing problems facing humanity? Climate change, poverty, disease,
Oh, wow.
the search for sustainable energy sources.
Yeah.
These are just a few of the challenges that come to mind.
I like the way you're framing this. It's not just about what quantum computing can do. It's about what we should use it for. We're not just passengers on this quantum leap. We have a responsibility to steer it in the right direction. But before we get too far ahead of ourselves, we need to take a step back and consider some of the philosophical implications of this technology.
Yeah.
We've talked about the practical applications. But what about the deeper questions that quantum computing raises about the nature of reality itself?
That's where things get really interesting. And maybe a little mind-bending. Join us after the break as we explore the philosophical side of the quantum revolution.
Welcome back to the Deep Dive. We've been on quite a journey today exploring the world of quantum computing.
It has been.
We've talked about the amazing potential, the anxieties it stirs up, and even how it might change our daily lives. But now it's time to get philosophical.
It's time to go down the rabbit hole. We've been discussing what quantum computing can do.
Right.
But what about what it tells us about the nature of reality itself? That's where things get really mind-bending.
Okay, I'm ready to have my mind bend. We touched on the strangeness of quantum mechanics earlier.
Yeah.
But how does quantum computing actually challenge our everyday understanding of the world?
Think back to the idea of superposition.
Okay.
That a qubit can be both 0 and 1 at the same time. This isn't just a mathematical quirk.
Right.
It suggests that reality at the quantum level is fundamentally different from what we experience. It's more fluid, more uncertain, full of possibilities rather than fixed states.
So it's like our everyday understanding of the world with its clear cause and effect is just a tiny sliver of a much larger, stranger picture.
Exactly. And quantum computing, by tapping into these bizarre quantum phenomena, is like holding up a mirror to that larger picture.
Yeah.
It's forcing us to confront the limitations of our classical intuitions.
So are we saying that quantum computers are going to unlock the secrets of the universe? I mean, that's a lot of pressure for a little chip.
Maybe not unlock all the secrets,
Okay.
but they're definitely a powerful new tool for exploring the unknown. Quantum computing allows us to simulate and study quantum systems in ways that were previously impossible. This could lead to breakthroughs in our understanding of everything.
Wow.
From the origins of the universe to the workings of the human brain.
Okay, now that's getting really interesting. Are we talking about finally understanding things like dark matter?
Yeah.
Or consciousness?
Yeah.
Is that the kind of potential we're dealing with?
Those are definitely areas where quantum computing could play a role. For example, some scientists believe that quantum computers could help us simulate the behavior of dark matter.
Really?
Potentially leading to a breakthrough in our understanding of this mysterious substance that makes up a large part of the universe.
Wow, so we could potentially use quantum computers to probe the deepest mysteries of the cosmos. That's incredible. But what about the philosophical implications for us?
Yes.
For humanity? If the universe is much weirder and more uncertain than we thought, what does that mean for our place in it?
That's a profound question, and one that philosophers will be wrestling with for generations to come. But I think quantum computing, in a way, is inviting us to embrace uncertainty, to accept that reality is not as fixed and predictable as we might like to believe.
It's like we're being asked to let go of our old ways of thinking and step into a world where possibilities are endless. It's daunting, but also incredibly exciting.
Yeah.
But I have to ask,
Yeah.
where do you think this quantum leap is taking us? What kind of future do you see when you look ahead?
It's impossible to predict the future with certainty, especially when we're dealing with a technology as transformative as quantum computing.
Right.
But I believe that if we approach it with wisdom, curiosity, and a strong sense of ethics, it has the potential to lead us to a future where we can solve some of humanity's greatest challenges and unlock a deeper understanding of ourselves and the universe we inhabit.
That's a beautiful vision, and one I think we can all aspire to. And on that note of hope and possibility, we come to the end of our deep dive into the world of quantum computing.
It's been fun.
We've covered a lot of ground today, from the technical details to the potential applications, the anxieties, and even the philosophical implications. We hope you've enjoyed exploring this fascinating topic with us.
I know I have.
We encourage you to continue learning, questioning, and imagining the possibilities. After all, as we've seen today, the future is full of quantum potential, just waiting to be discovered. Thanks for listening.